Imagine having an AI assistant that can predict your future, but how do you know if it's really working? AI testing is a crucial step in understanding whether your AI model is accurate, trustworthy, and reliable. But let's be honest, AI testing can be a complex and daunting task, especially for those new to the field. The truth is, AI testing is more than just throwing data at a machine. It's about understanding the intricacies of AI decision-making. It's about recognizing the potential biases and flaws in your AI model and taking steps to mitigate them. It's about ensuring that your AI is not just smart, but also fair, transparent, and accountable. But where do you start? With so many types of tests and testing methods available, it can be overwhelming to choose the right approach for your specific AI project. That's why, in this section, we'll explore the basics of AI testing, including the different types of tests and their purposes. We'll also discuss the importance of choosing the right testing method for your AI project. Let's start with the basics. AI testing can be broadly categorized into four main types: unit testing, integration testing, system testing, and acceptance testing. Unit testing involves testing individual components or modules of your AI model to ensure they are working as expected. Integration testing, on the other hand, focuses on testing how different components interact with each other. System testing involves testing the entire AI system to ensure it meets the required specifications and standards. Acceptance testing is the final step, where the AI system is tested to ensure it meets the requirements of the end users. Each of these testing types serves a specific purpose, and choosing the right approach depends on your AI project's requirements and goals. For example, if you're building a chatbot, you may want to focus on integration testing to ensure that the chatbot's natural language processing, NLP, and machine learning algorithms are working seamlessly together. On the other hand, if you're developing a predictive analytics model, you may want to focus on system testing to ensure that the model is accurate and reliable. But here's the thing, AI testing is not a one-size-fits-all solution. Different AI projects require different testing approaches, and what works for one project may not work for another. That's why it's essential to choose the right testing method for your AI project. So, how do you choose the right testing method? The answer lies in understanding the specific needs and requirements of your AI project. For instance, if your AI project involves high-stakes decision-making, such as medical diagnosis or financial forecasting, you may want to focus on more rigorous testing methods, such as simulation testing or data-driven testing. On the other hand, if your AI project involves more routine tasks, such as data entry or customer service, you may want to focus on more straightforward testing methods, such as unit testing or integration testing. In addition to choosing the right testing method, it's also essential to consider the following factors: data quality. AI testing relies heavily on high-quality data, and poor quality data can lead to inaccurate results and biased AI models. Testing scope. Determine what aspects of your AI project need to be tested, and what aspects can be skipped. Testing frequency. Decide how often you need to test your AI model, and whether you need to test it continuously or periodically. Testing tools. Choose the right testing tools and software to support your testing efforts. By considering these factors and choosing the right testing method, you can ensure that your AI model is accurate, trustworthy, and reliable. But that's not all. AI testing is an ongoing process, and it requires continuous monitoring and improvement. In the next section, we'll explore some advanced AI testing techniques, including simulation testing, data-driven testing, and adversarial testing. We'll also discuss how to use these techniques to improve the performance and robustness of your AI model. For now, let's recap what we've covered so far. AI testing is a crucial step in understanding whether your AI model is accurate, trustworthy, and reliable. AI testing involves understanding the intricacies of AI decision-making and mitigating potential biases and flaws. There are four main types of AI testing: unit testing, integration testing, system testing, and acceptance testing. Each testing type serves a specific purpose, and choosing the right approach depends on your AI project's requirements and goals. AI testing is not a one-size-fits-all solution, and different AI projects require different testing approaches. Before we move on to the next section, I want to leave you with a question. What's the most critical aspect of AI testing that you need to consider when building your AI project? Share your thoughts in the comments below, and let's keep the conversation going. And if you're new to AI testing, don't worry, we'll cover everything you need to know in this series. Stay tuned for the next section, where we'll dive deeper into advanced AI testing techniques and explore how to use them to improve the performance and robustness of your AI model. The future of AI is exciting, and with the right testing methods and approaches, you can build AI models that are accurate, trustworthy, and reliable. But it's not just about building AI models. It's about using them to make a positive impact on the world. So, let's get started on this journey, and let's explore the world of AI testing together. Are you ready to put your AI to the test? Before you start, you need to prepare it for the challenge. Think of it like training for a marathon. You can't just show up on the day and expect to win. You need to put in the groundwork, build your endurance, and fine-tune your skills. In this section, we'll discuss the crucial steps to prepare your AI for testing, ensuring you get accurate and reliable results. First, let's talk about data quality. A robust and representative dataset is the foundation upon which your AI model is built. Think of it like a house. If the foundation is weak, the entire structure will collapse. Your dataset needs to be diverse, inclusive, and free from biases. Imagine trying to train a model to recognize different types of animals using a dataset composed entirely of cats. It's not going to work very well, is it? You need to gather data from various sources, including images, text, audio, and even videos. This will help your AI learn to generalize and make more accurate predictions. But how do you ensure your dataset is representative? One approach is to use a technique called stratified sampling. This involves dividing your data into distinct groups or strata, such as age, location, or occupation. Then, you randomly select a subset of samples from each group to include in your dataset. This ensures that your data is diverse and representative of the broader population. For example, if you're building a model to predict credit risk, you might use stratified sampling to include a range of age groups, income levels, and credit histories. Another important aspect of data preparation is selecting the most relevant types of data for your project. Not all data is created equal, and some types of data are more suitable for AI testing than others. For instance, if you're building a model to recognize objects in images, you'll need to use datasets containing high-quality images with clear labels. However, if you're building a model to predict text sentiment, you'll need to use datasets containing text data with labeled emotions. The key is to understand the specific requirements of your project and select the most relevant data types to achieve your goals. Now, let's talk about common pitfalls in data preparation. One major mistake is using biased or incomplete data. Imagine trying to train a model on a dataset that's been curated by a single person with a particular worldview. The results will likely be skewed and unreliable. Another pitfall is using low-quality data, such as images with poor resolution or text data with typos. This can lead to poor model performance and inaccurate predictions. To avoid these pitfalls, here are some pro tips. 1. Use diverse and representative data. Make sure your dataset is diverse and representative of the broader population. 2. Use stratified sampling. Divide your data into distinct groups and randomly select a subset of samples from each group. 3. Select the most relevant data types. Understand the specific requirements of your project and select the most relevant data types to achieve your goals. 4. Use high-quality data. Use high-quality data with clear labels and minimal errors. 5. Avoid biased or incomplete data. Be aware of potential biases and incomplete data and take steps to mitigate them. By following these tips, you'll be able to prepare your AI for testing and get accurate and reliable results. Remember, data preparation is a critical step in AI testing, and it's essential to get it right. In the next section, we'll discuss the different types of AI testing and how to select the most relevant one for your project. Before we move on, let's take a moment to reflect on what we've covered so far. We've discussed the importance of data quality and how to ensure your dataset is robust and representative. We've also explored the different types of data used in AI testing and how to select the most relevant ones for your project. Finally, We've addressed common pitfalls in data preparation and provided tips for avoiding them. In the next section, we'll delve deeper into AI testing and explore the different types of testing methods available. But for now, let's take a closer look at a real-world example of AI testing. Imagine you're a marketing manager at a large e-commerce company, and you want to test the accuracy of your AI-powered product recommendation engine. You've prepared a dataset of customer purchase history and product features, but you're not sure which testing method to use. In this scenario, you might use a type of testing called a B testing, where you randomly split your customers into two groups and show them different product recommendations. By comparing the results, you can determine which recommendations are more effective and make data-driven decisions to improve your product. We'll explore more examples like this in the next section, but for now, let's summarize what we've covered so far. We've discussed the importance of data quality, the different types of data used in AI testing, and common pitfalls in data preparation. By following these tips and using the right testing methods, you'll be able to get accurate and reliable results from your AI model. Before we move on, I want to ask you a question. What's the most challenging part of data preparation for you? Is it selecting the right data types, avoiding biases, or something else entirely? Let us know in the comments below, and we'll do our best to help. In the next section, we'll discuss the different types of AI testing and how to select the most relevant one for your project. Stay tuned. From unit tests to integration tests, we'll delve into the different types of AI tests and how to use them effectively. So, what exactly is unit testing? In simple terms, unit testing is a way to verify that individual components of your AI code are working correctly. Think of it like testing a single Lego brick to ensure it fits perfectly with the rest of the structure. By writing effective unit tests, you can catch bugs and errors early on, saving you time and resources in the long run. Let's talk about how to write effective unit tests. First, you need to identify the individual components of your AI code that need testing. This could be a specific function, a class, or even a small piece of code. Once you've identified the components, you can start writing unit tests for each one. A good unit test should be independent of other tests, meaning it shouldn't rely on the outcome of another test. Think of it like testing a single ingredient in a recipe without relying on the other ingredients. When writing unit tests, make sure to include a few key elements. First, you need to specify the input and expected output of the code being tested. This could be a piece of data, a specific value, or even a scenario. Second, you need to include any necessary setup or teardown code to ensure the test runs smoothly. Finally, you need to include a test assertion, which is a way to verify that the code behaves as expected. Let's take an example. Imagine you're building an AI that can predict stock prices. You've written a function that takes in historical data and returns a predicted price. To test this function, you could write a unit test that inputs a specific set of historical data and checks if the predicted price is within a certain range. If the test passes, you know your function is working correctly. Now, let's move on to integration testing. Integration testing is a way to verify that multiple components of your AI code work together seamlessly. Think of it like testing a fully assembled Lego structure to ensure all the bricks fit together perfectly. By combining multiple unit tests, you can ensure your AI system works as a whole. When performing integration testing, you need to consider a few key things. First, you need to identify the interfaces between different components of your AI code. This could be a function call, a data exchange, or even a network request. Second, you need to write tests that simulate real-world scenarios, taking into account edge cases and unexpected inputs. Finally, you need to ensure that your integration tests are independent of other tests, just like unit tests. Let's talk about edge cases. Edge cases are scenarios that occur when your AI code is pushed to its limits. This could be a large dataset, a complex input, or even an unexpected error. By including edge cases in your testing process, you can ensure your AI system behaves as expected in real-world situations. For example, imagine you're building an AI that can recognize objects in images. You've written a function that takes in an image and returns the recognized object. To test this function, you could write an integration test that inputs a variety of images, including ones with low resolution, poor lighting, or even multiple objects in the same scene. By including edge cases like these, you can ensure your AI system works as expected in real-world situations. In conclusion, unit testing and integration testing are two essential types of AI tests that can help you ensure your AI system works correctly and reliably. By writing effective unit tests, you can catch bugs and errors early on, saving you time and resources in the long run. And by performing integration testing, you can ensure your AI system works as a whole, taking into account edge cases and unexpected inputs. By including edge cases in your testing process, you can ensure your AI system behaves as expected in real-world situations. So, next time you're building an AI, remember to include unit testing and integration testing in your testing process, and you'll be well on your way to creating a reliable and trustworthy AI system. Take your AI testing to the next level with advanced techniques like fuzzing and adversarial attacks. In the previous sections, we've covered the basics of AI testing and how to prepare your AI for the challenge. But now it's time to take it up a notch and explore the more advanced techniques that will help you identify and fix even the most elusive bugs. Let's start with fuzzing. Fuzzing is a testing technique that involves feeding your AI random or malformed input to see how it reacts. It's like throwing a bunch of different foods at a chef and seeing how they respond. The goal of fuzzing is to identify how your AI handles unexpected or invalid input, which can help you catch issues that might not have been caught otherwise. To implement fuzzing, you'll need to use a fuzzer tool, which can be integrated into your testing pipeline. There are many different types of fuzzers available, ranging from simple command line tools to more complex frameworks. When choosing a fuzzer, consider the type of input you're testing and the level of complexity you need to achieve. One popular fuzzer is AFL, American Fuzzy Lop, which uses a combination of genetic algorithms and feedback loops to generate new test cases. AFL is particularly effective for testing complex systems, such as neural networks, and can be used in conjunction with other testing techniques for even better results. Now that we've covered fuzzing, let's talk about adversarial attacks. An adversarial attack is a type of attack that involves creating input designed to fool or mislead your AI. These attacks can be used to exploit vulnerabilities in your AI and can be particularly difficult to detect. To defend against adversarial attacks, you'll need to implement robustness and security measures in your AI. One effective way to do this is by using techniques like data augmentation and regularization, which can help your AI generalize better and become more resistant to attacks. Another technique for defending against adversarial attacks is to use adversarial training. Adversarial training involves training your AI on a mix of normal and adversarial examples, which can help it learn to recognize and reject malicious input. This technique can be particularly effective for neural networks, which are notoriously vulnerable to adversarial attacks. Finally, let's talk about generative models in AI testing. Generative models are a type of AI that can generate new data, such as images or audio, that mimics real-world examples. These models can be used to create realistic test cases that can help you identify and fix issues in your AI. One popular generative model is the Generative Adversarial Network, GAN, which uses a combination of a generator and a discriminator to create new data. GANs can be used to create realistic images, audio, or even entire datasets, which can be used to test your AI and identify issues. To harness the power of generative models in AI testing, you'll need to use a combination of techniques, such as data augmentation and transfer learning. Data augmentation involves modifying existing data to create new examples, while transfer learning involves using pre-trained models to fine-tune your AI. In the next section, we'll explore more advanced techniques for AI testing, including testing for bias and fairness. We'll also cover how to use these techniques to improve the robustness and security of your AI. But for now, let's take a moment to reflect on what we've covered so far. We've explored the basics of AI testing, prepared your AI for the challenge, and taken it up a notch with advanced techniques like fuzzing and adversarial attacks. So, you've made it this far, but are you ready to put it all together and create a comprehensive AI testing strategy? In this section, we'll summarize the key takeaways from our previous sections and highlight the most important considerations for AI testing. Let's start with the basics. What makes a good AI testing strategy? It's all about identifying and addressing the unique challenges of your AI system. This means understanding the nuances of your AI's strengths and weaknesses, as well as the potential risks and rewards of using it in a real-world setting. One key takeaway from our previous sections is the importance of continuous testing. This means regularly testing and refining your AI system to ensure it's performing as expected and adapting to changing conditions. To do this effectively, you'll need to integrate testing into your development workflow, using tools and techniques that help you identify and prioritize areas for improvement. So, how can you put this into practice? Here are a few actionable next steps to get you started. Identify the key performance indicators, KPIs, that matter most for your AI system, and create a plan for regularly testing and refining these metrics. Integrate testing into your development workflow, using tools and techniques that help you identify and prioritize areas for improvement. Regularly review and refine your testing strategy to ensure it's aligned with your evolving business needs. Now, let's talk about the importance of continuous testing in more detail. Why is it so crucial for AI systems, and how can you make it a part of your development workflow? One key reason is that AI systems are inherently complex and dynamic, with many variables that can affect their performance and behavior. To address this complexity, you'll need to use a range of testing tools and techniques, including unit testing, integration testing, and end-to-end testing. You'll also need to integrate testing into your development workflow, using tools and techniques that help you identify and prioritize areas for improvement. Here's an example of how you can use continuous testing to improve the performance of your AI system. Create a testing plan that identifies the key performance indicators, KPIs, for your AI system and sets clear targets for improvement. Integrate testing into your development workflow, using tools and techniques that help you identify and prioritize areas for improvement. Regularly review and refine your testing strategy to ensure it's aligned with your evolving business needs. By following these steps, you can create a comprehensive AI testing strategy that helps you identify and address the unique challenges of your AI system. Remember, AI testing is an ongoing process that requires regular testing, refinement, and adaptation. By staying on top of these challenges, you can unlock the full potential of your AI system and achieve remarkable results.